everyone. It is 12:04, and I will call this
Heather,
meeting
can you hear me?
of the Town Council to order. I'd like to acknowledge that we are meeting in Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people. And I will look for a motion to approve the agenda. Moved by Councillor Duggan, seconded by Councillor Ernst. All those in favor? Opposed? Motion is carried. We only have one item of business, which is the near-term upgrades and outfall extension report plus implementation plan. We have the engineers from CBCL with us to deliver that report, and so we will turn the floor over to them.
Thank you, Your Worship. Thank you for the opportunity to present to you today. First, I'd like to introduce my team. Alan McCulley, Civil Engineer, Nick Moriarty, Process Specialist, Erica Hart, Process EIT, and myself, Sarah Enslin, Process Engineer. Could you please change the slide? Okay. This presentation is an update and a follow-up to some previous presentations that we've done on the wastewater treatment plant project. No decision is needed at this time. We'll be presenting two draft reports to you today. The first of these is the outfall report and also the near-term report. And please move to the next slide. So first, I'm going to take you on a quick tour of the plant so that you know what it involves and what the different pieces are in it. Wastewater enters at the headworks where it's screened of large solids, and that's at number 1 in the bottom left corner. And then it moves to the bioreactor tanks, which have bacteria on floating plastic media where organic matter is removed. And that's at number 2. Then it goes to the equalization tanks where it's batched to flow through the dissolved air flotation tanks or DAF tanks at number 4, and there the solids are removed. After that, it goes through the ultraviolet disinfection where bacteria is removed or killed essentially, and then to the effluent pump station from where it's pumped to the outfall under the inshore fisherman's wharf. The solids removed from the DAFs are pumped to the sludge holding tanks, and from there to the sludge dewatering process where it is dewatered to send off-site for disposal. And then the biofilter in the top right corner is for odor control on site. Next slide, please. I'll first give a short update to the long-term expansion. We're currently in the process of revising the report following staff comments and discussions. And there are 5 expansion options that were considered and compared in this report. There's a moving bed bioreactor upgrade, which uses the existing DAFs, but adds capacity to the moving bed bioreactor. A moving bed bioreactor and DAF upgrade, which replaces the dissolved air flotation tanks as well. A change to a completely different process, that's a sequencing batch reactor. And another process change in a membrane bioreactor or MBR, and finally option 1, but with effluent polishing for better effluent quality. These will all be presented in detail at the next presentation taking place next week. Next slide, please. Now I'll move on to the near-term upgrade items. These are things that are currently giving problems at the plant or the items in the plant that are at the end of their design life and in need of replacement. They require upgrades or replacement even with the current capacity of the plant, so before any additional population loading is included. And these are presented in priority order. They're all numbered. The 2 highest priority items from our ranking of all of these near-term upgrade items are the flood control berm and the UV disinfection capacity upgrade. These 2 are ones that have been causing problems historically, and we feel that these are the 2 that are the most important to move forward on in the short term. These were ranked by looking at the criticality of each of them, the opportunities for process improvements, for operational improvements, the cost, and also how well they fit in with the proposed long-term expansion options. So there's 11 of these altogether, and there are 5 in the high priority category, which include the flood control berms, UV disinfection, polymer dosing pumps, aeration blower replacement, and headwork screen and compactor replacement. Then there are also 3 medium priority and 3 lower priority. And at this point, I'm going to turn it over to Erica Hart to go through, actually not quite yet, one more slide and then I will. Next slide, please. Okay. The first item and the highest priority one in our prioritizing ranking is a flood protection berm. As you're no doubt aware, during Hurricane Dorian, the wastewater treatment plant suffered significant flooding to the process room, which damaged a number of pieces of equipment, which then had to be replaced. And the plant did not return to full service for at least 6 weeks following that storm. And it continues to be at risk from storm surges and also from heavy rainfall. And as the years go by and climate change becomes more of an issue, that risk is only going to increase due to severity of storms and also the intensity of rainfall. The original idea was to replace it with a tide gate that would be at the outlet to the marsh. But when we did additional analysis on this as part of this project, we found that it was riskier than we had anticipated it would be. It did not control the water levels under heavy rainfall with climate change effects included, as well as we had originally thought that it would. And it also left some risk, significant risk to the town staff in trying to both access the gate in order to operate it at the correct times and also make the right decisions on exactly when to open and close the gate. But because of this, we changed our concept to a berm concept that is much more passive. The berms would close off the areas in which water can currently come from the marsh or from Star Street up into the lower lying plant area and the process room. There are some pipelines that would need to exit through this berm, and they would be equipped with check valves so that water could only exit but not come back up. There is a cross section of the berm in the bottom right-hand corner, and it should be noted that the scale is exaggerated, so it is not actually as steep as it appears in the picture, but it gives an idea of what it looks like in a cross section. There'd be 2 berms needed, one to close off the opening to the marsh and one on Star Street side to make sure that there's always a higher elevation area of land surrounding the whole plant. And this would leave the driveway accessible. The advantages of this are that it doesn't require the staff to make that decision on when to open and close the gate, and it would be able to exclude storm surge water, including predicted climate change effects, while not affecting the stormwater drainage from the marsh itself. There would be occasions on which a trailer pump would be needed to pump out the area of that lower driveway itself during a heavy rain because the marsh could be backed up so much that the water couldn't drain by gravity anymore. But it would be a manageable size trailer pump that could handle that flow. And so this is what we're now proposing for flood control at the plant. And now I will pass it over to Erica to talk about the other near-term items.
Mhm.
The next item that we would like to speak about is the UV disinfection. Sorry, next slide. Okay, perfect. The existing UV system is currently underpowered to provide a sufficient dose to the wastewater due to low UV transmittance in the summertime. This is influenced by TSS in the wastewater stream, overdosing of polymer, as well as color in the wastewater stream. It is proposed that we would increase the capacity of the UV system by adding an additional bank of UV directly upstream of the existing bank in the existing channel. This would allow the wastewater treatment plant to consistently meet all the bacterial regulatory limits year-round. The next item is the polymer dosing pumps. Polymer is dosed ahead of the dissolved air flotation units to aid in the removal of suspended solids. The existing pumps are nearing their end of design life and are in poor condition. Are required to be replaced at the very minimum. It is proposed that we would implement a new dosing skid with 2 progressive cavity pumps, one dedicated to each dissolved air flotation tank, along with additional monitoring and controls to improve the control of the polymer dosing to the DAF system. Next slide, please. The next item is the aeration blowers. The blowers supply air to the membrane bioreactor, which is critical in removing the biological components from the wastewater. They also supply air to the sludge equalization tank the sludge holding tank, as well as the equalization tank to avoid septicity, as well as provide mixing. The blowers are nearing the end of their useful design life, and furthermore have been discontinued by their manufacturer, making the spare parts difficult to find and difficult to complete repairs in the future. It is proposed that new blowers of the same capacity, but a newer model and improved efficiency be replaced. At the inlet of the plant, there is a 3-inch bar screen that prevents large debris from entering the treatment plant and protects the downstream equipment. Currently, the bar screen is not providing sufficient protection to the downstream equipment, such as the aerated grit tanks, as well as the MBBR. We propose to install a new screen, a perforated plate screen that will improve the capture efficiency of debris from 50% to 75%. This will reduce additional maintenance of the downstream equipment at the plant. Currently, there is no standby power at the wastewater treatment plant, leaving the plant vulnerable during power outages. We propose to install a new standby generator of 600 volts out at the outside of the treatment plant on a concrete base. The generator will be supplied with a underground diesel tank to provide a 24-hour storage of fuel at the full load. The generator is sized such that all of the key equipment of the wastewater treatment plant can be serviced during a power outage. And this upgrade will also include an expansion of the electrical room, which would increase the capacity of the electrical distribution panel for future needs. Oh, sorry, next slide, please. Sorry, I can't read it. Additionally, we would like to supply online instrumentation to the membrane bioreactor. There's currently little instrumentation that allows for monitoring or control of the system and accurate dosing of the polymer. Polymer overdosing has been seen at the outlet of the wastewater treatment plant in the harbor, as well as causes foaming issues within the plant that becomes a maintenance issue. Additional instrumentation would allow the polymer to be dosed accurately based on the inlet conditions of the wastewater. As seen from a DAL study, the main parameters are salinity as well as TSS. So we would propose to add TSS meters as well as conductivity meters to measure the salinity and TSS, along with dissolved oxygen meters within the equalization tank and the MBBR. The mechanical upgrades at the plant include various areas. The first area is within the blower room. There is significant heat gain, mostly from the 3 blowers operating, and happens more often in the summer when there are 2 blowers operating at the full capacity. This causes overheating in the blower room. It is proposed to remedy this by insulating the air header to reduce the heat rejection from the overhead piping, as well as reinstall an exhaust fan to provide proper heat relief within the room. The bioreactor building currently has no water supply. This is an issue because there is maintenance that is required to be carried out periodically to wash down the walkways. And the only way to complete this currently is by having the fire department come and use their hoses to wash things down. The proposed upgrade is to provide a water supply line directly to the bioreactor with 2 hose reels at either end so that proper cleaning of the walkways can be completed. The final mechanical upgrade is to improve the H2S control in the process room. There has been instances of high H2S accumulation within the middle of the process room, typically at the floor level. This is a health and safety issue and can be remedied by improving the ventilation at both the ceiling level as well as improving the location of various ducts to remove H2S from the floor level. The next options are the lower priority items that include modification to the polymer makedown system, the DAF weirs, and the compressor pipework. The polymer makedown system is a system that makes down dry polymer into its usable form for dosing. The current equipment is nearing its end of useful life and does not have proper instrumentation to verify its activation level. We propose to install a new system that has improved instrumentation and metering to verify its activation and make down efficiency. The next item is the DAF weirs. The DAF weirs currently are non-adjustable, which is a maintenance issue at the plant as they have to be cleaned about every 3 to 6 months. In order to improve their ability to be maintained, we are proposing that they be made into movable weirs that are adjustable via a hand wheel. This would require a visit from the vendor to the site to fully explore this option. The final item is the compressor pipework. Compressed air is used throughout the plant to actuate various valves and the pipework is showing signs of corrosion in some areas. It is recommended that the pipework be fully inspected and replaced as required. And it's again noted that these 3 items are lower on the priority list. And I'll pass it back to Sarah.
Okay. Thank you very much, Erica. Now we'll present the cost for the near-term item upgrades. The opinion of probable costs for each of these items includes design development contingency, because this is still at a fairly early stage of design. So that is for unknowns that are discovered during the design process or additional features that the town might want to include during the design process, as well as construction contingency for unknowns that are discovered during the construction process. And it also includes an allowance for engineering. So as noted before, the top priority items are the flood control berms at a cost of $212,000, is our opinion of probable cost, and the UV disinfection upgrades at $218,000. Also important would be the polymer dosing system, although it should be noted that the cost here is for a full replacement of the polymer dosing skids, and that it would be possible to do a minimal upgrade to these to just replace the polymer pumps themselves if the town did not want to pursue a long-term option that included the polymer dosing system. Then following on from that, headworks modifications at 634,000 and aeration blower upgrades at 617. Online instrumentation at just under 100,000. The standby generator cost is over $1 million. And the reason for this relatively high cost is that the current electrical room does not have the space to add in the necessary equipment to not only have a standby generator, but an automatic transfer switch that would switch over whenever there was a power outage that would not require an operator to manually switch it. And then following that, there are building mechanical upgrades and then the lower priority items that could be deferred until later if necessary. Okay, next slide, please. Okay, and at this point, I would welcome any questions on the near-term item upgrades.
Okay, we'll open the floor to questions from councilors. Councilor Dudley.
Okay, my first question is, so what is the time frame for the lower priority items in terms of, you're saying that they're lower priority, but when would they need to be done by? So if we don't do them now, what happens?
Okay. Some of those items are connected to the long-term items. So if the town chose a long-term option that did not include a polymer dosing system, it might be possible to not do the polymer makedown upgrade. However, depending on the timing of that long-term expansion as well, we'd recommend that that work be done in the next 10 years if it isn't, like, even if the expansion is still planned to take place beyond that time period. So I would say 5 to 10 years for those lower priority items if the town wants to pursue them and the expansion has not yet taken place or is not going to, or will still use those items. Is that? Okay.
Councilor Halverson.
It's actually, you touched on my question in your answer, actually. I was wondering, in all of these upgrades, how much of that could be repurposed? And I guess that would be dependent, obviously, on whatever solution we all decide to go with for the long-term solution.
Mhm.
Is that? But I mean, regardless of what we choose, I'm looking at things like, you know, the generator obviously can be repurposed, a trailer pump, that kind of thing. You know, but yeah, I guess can you give me some indication about, you know, things like that we could possibly reuse?
Mhm. Yes, thank you.
Mhm.
There are, most of the items included in those can be repurposed. The only ones that can't be are the last 3 items, which may not be relevant if you go a different direction with the long-term expansion. All of the other items are relevant and would be used in any of the long-term expansion options. They might look slightly different based on what was chosen, but they'd be very similar and would be reused.
Just one more follow too. And on that trailer pump, I assume that's a piece of equipment we're looking at purchasing and will remain on site. It's not something we're going to bring in from an outside supplier when necessary. Obviously, when we need it, we have to have it immediately, right?
I believe the town already has a suitable pump that could be used for that purpose.
Even better. Thanks.
Deputy Mayor.
Thanks, Your Worship. This is Sarah. So Sarah, I mean, would it be safe to say that we really can't proceed in any of the short-term, you know, fixes until we really understand what our long-term fix would be? So like, it's not really decision time here today. It's really after we hear your long-term report. Would that make more sense than to start seeing what we might do on a short-term basis?
Some of them are connected, but the top 2 priority items are not connected. Those would look exactly the same for any of the long-term expansion options. And with the polymer pump replacement, at least the minimal pump replacement needs to be done within the next year or so. And so it again would not be affected by the long-term choice in any way.
And that was sort of like that leads in real to my next question. Like, I mean, you mentioned short-term 5-10 years. That to me, that's my long-term plan, right?
Mhm.
So, you know, it's kind of like, I'm thinking 2 or 3 year type of thing rather than, once we get into 5 and 10, I think we've got to be really more aware of what our long-term plans are going to be.
Yeah, so the lowest priority 3 items, those I think could be put off till the 5 to 10 year timeframe, but the other ones are in the 2 to 3 year timeframe rather than 5 to 10.
Now, then the other question I have is like now, we've heard a lot about saltwater infiltration. I haven't heard anything here. I know we're working on it, but I mean, to what level have we spent so far, in terms of what have we done and what have the cost us so far?
There has been some work on it at Brook Street that was quite successful in excluding saltwater from the system, but it is an ongoing process to gradually increasingly exclude it from the system. From the DAL work, and they're going to present next week, I believe, as well, they found that the saltwater had a very significant effect on the effectiveness of the solids removal and the amount of polymer that was needed to remove solids at high salinity. And so it's clearly something that has been negatively affecting the performance of the solids removal equipment. And the more that it can be excluded, the more reliable and stable the operation of the existing system would be. I don't know exactly what has been spent to date. We'd need to go to the engineering staff to get more details on that.
And just one more. And what's the significance then of our collection system with our long-term plan as well?
The long-term expansion assumes that there will be significant sewer separation that takes place within Lunenburg in order to hold the flows at no higher than they are currently, especially for peak flows. Now, at the moment, the plant rarely reaches its peak flow, and the average flow includes a lot of stormwater. So the average flow per person in the town is significantly higher than in comparable towns that don't have large areas of combined sewer. And by prioritizing the key areas where that problem is the worst and separating those, there is a lot of potential to reduce flows in the shorter term and to allow the town to grow without expanding the flows overall.
So do you think you'll be able to address that, say, system ABC will be dependent on what level of collection that we may have? So like, system C will be 100% effective if we control, if we increase our collection by, quality by 40%, right?
Well, the main pieces of equipment that are dependent on flow are the headworks, which would need to be, increased capacity if the town doesn't want to or isn't able to significantly and control the stormwater getting into the system. And with any of the process changes, it would be possible to simply size the system appropriately so that it could handle the increased flow, but that comes at a significant cost as well and means that you're building a lot of extra capacity into the new plant that you potentially don't need. So therefore, we would recommend that efforts to identify where those areas are and separate them in line with best practices now would be taken in order to make the future plant a reasonable size for the town rather than oversized to try to treat a lot of extraneous water, including both seawater and stormwater.
Yeah. So we could actually expand our town 20% and actually reduce our collection, like our capacity, right?
Yes.
Yeah. Okay, thanks a lot.
Okay. Councillor Ernst?
Thank you. Just getting back to the generator, one of the other possible long-term things that we're potentially looking at is the possibility of introducing solar energy into the plant. So just wondering, at 1.3, I think it was, and for this generator and a large underground diesel tank, seems rather obtrusive. How would that affect in the long term? Should we choose to go to a more alternative route? Has that been looked at or discussed along with this?
That's not something that we've looked at directly. The standby generator would be used in cases of power outage, which presumably could still occur even if the town was generating some of their own electricity. And that was not directly looked at in our report. So as both of those develop further, then it would be useful to make sure that they are compatible. But I don't see any reason why they would not be compatible.
Okay. Any further questions from council? I have a quick one just following on the thread of capacity. In terms of the near-term upgrades outside of, dealing with combined sewer, will those generate any increase in capacity at the plant itself?
There would be a significant increase in the UV disinfection capacity. That would double in order to allow the plant to consistently meet the bacterial regulatory limits. The other ones would mostly not increase plant capacity. The aeration blowers could have some ability to increase capacity, but most of these are really about reliability, so making sure that the plant is operating as it needs to, rather than increasing the capacity for future loading.
Mhm. So then you wouldn't anticipate an increase in capacity at the plant itself potentially until 10 years out?
Well, that I suppose would depend on how quickly the town wanted to proceed with the long-term expansion.
Mhm.
If that goes ahead quite quickly, then you would have the extra capacity as soon as it was constructed. And if it was more of a long-term plan or more gradual population growth, then you might choose to stay with the existing process until the time that the expansion was clearly needed.
Yeah, or go the alternative route of combined sewer separation. Right. Okay. Want to move on to the next section?
Okay. So for the outfall extension, we looked initially at 6 different options. The location of the existing outfall is shown at the star, and we looked at 6 other options spread around the front and the back harbor. And going through a Kepner-Trego decision analysis process, the top 2 options of these 6 were option 3 at Burma Road and option 4 near Highliner. And these were the 2 that were recommended after the initial memo and dispersion modeling to take forward for pre-design and costing. So I'll update you on options 3 and 4 today. Okay, next slide, please. And we did dispersion modeling of various options in the harbor to see what the effect would be. And we noted that the existing location had very poor dispersion potential, while the best modeled dispersion potential was at option 4 near the Highliner plant. And on that slide, red indicates a higher proportion of effluent in the harbor water, and purple and blue indicate a lower proportion. So you can see that options 3 and 4 have significantly better than existing dispersion potential, and that in both of those 2 locations, it's considered good. Okay, next slide, please. So the option 3 and 4 routes are on this slide compared to the existing outfall route. That one is shown in orange, and it leads from the wastewater treatment plant to the existing outfall under the inshore fisherman's wharf, down Star Street and across town. And it's pumped from the effluent pumps that are in the wastewater treatment plant. The other two options, options 3 and 4, would turn the other way down Star Street and then go on to the Back Harbor Trail. They would go around town on the Back Harbor Trail up till it nears the Blue Rocks Road and then go cross country to the Blue Rocks Road and down that one towards Burma Road and towards Shore Road, depending on which of those two options was selected. And both of these options require pump upgrades to the effluent pumps at the wastewater treatment plant because they're pumped over a higher elevation than the existing outfall route is. The pumps for option 4, or at least the motors for option 4, would need to be larger than the motors for option 3 and would therefore also use more electricity in running costs. And we have allowed in our opinion of probable costs for pump replacement because those pumps are, again, about 20 years old, and thought that would might be something the town would want to look into at this point to ensure good future performance. Along this route, there's also several air release valves and some drains at the low points so that the line can be drained for maintenance if necessary. For option 3, it's a force main or a pressurized pipe up until just about where it joins to Blue Rocks Road, and then it becomes a gravity pipe flowing down the hill and down Burma Road and to a point about 100 meters off the shore. For option 4, then the pipe stays as a pressurized pipe until a location on Shore Road, and there it flows into a manhole and becomes a gravity pipe for the rest of the way down Shore Road, both the maintained length of Shore Road and also the unmaintained length of Shore Road, until it comes down to the coast and goes again about 100 meters offshore. However, at this location, it does have to come down quite a steep slope. So the construction of this option is more complicated and will require more stabilization following construction. It's also more complicated from a regulatory perspective because there are more stakeholders that would need to give permission for the construction of an outfall in option 4 location. The pipe sizes for the force main is in both cases a 14-inch pipe, and for the gravity section will be a 15-inch pipe. This is to get a balance between the flow going fast enough that solids don't settle out into the line, and also not so fast that there's excessive energy losses due to friction. And for pipe materials, we're recommending the use of PVC pipe, which is a type of plastic pipe. This is resistant to corrosion and has a long life in wastewater service, and it's also lightweight and relatively quick to construct. However, high-density polyethylene might also be a viable option, and it would be possible to, in the tender package, have both as an option so that you could get the most effective material. HDPE is also plastic, so it has similar advantages to PVC, but it can be laid in longer lengths. Okay, next slide, please. At the end of each of the outfalls, we would recommend that there is not just a pipe that ends and the wastewater coming out of it, but that there's a set of diffusers on the end of each of the outfalls. And these are smaller pipes that have a duckbill check valve on the end, so the water can only leave the pipe but not come back in. This reduces the visible appearance of the outfall on the surface and also provides additional dispersion potential because it spreads out the effluent over a larger area. The specific design of the diffusers would be done during detailed design. And this section is a typical view of one that we've designed in the past. It would be most likely fairly similar, although it probably wouldn't have rock around it in the particular location in question. And then the photograph in the bottom corner is one that was being installed in another location in Nova Scotia. This has an HDPE pipe, which would be typical for the outfall pipe, and the same type of concrete collars to weight it down. The actual installation would look a bit different because it would be in deeper water, but it does give you an idea of the type of pipe and collar that are used for these kind of outfalls. Okay, next slide, please. Okay, to compare each of these options, option 3, the Burma Road option, our opinion of probable cost for this one is $2.6 million. This includes design development contingency for unknowns during the design process, construction contingency for unknowns encountered during construction, and also an allowance for engineering. And due to the volatility of plastic prices at the moment, then there are higher contingencies for design development than we used on the near-term items, because that's a risk on this particular project. The advantages of option 3 are that it is lower cost, both for capital costs and for the operating costs. And it also has a simpler routing, which leads to less permitting being required for this option. The disadvantages of the option are that it does have lower dispersion potential than option 4, but it still looks much better than before and likely to be acceptable from a regulator's perspective. Then for option 4, the opinion of probable cost for this option is $3.1 million. Its main advantage is that it has better dispersion potential, but counter to the other one, it has more complicated routing. It's harder to get down to the shoreline. There's more infrastructure that needs to be avoided on that route. More regulatory parties who would need to be consulted and applied to for permits, and it also has both a higher capital and operating cost. So in light of this, and following a Kepner-Trego decision analysis process on these two specific options to look at both of them compared to each other, we recommend that option 3 is the preferred option for an outfall extension for the town, and that option 4 would be a backup option that we think is also viable, but not as attractive as option 3 at this point. Okay, next slide, please. Okay. The next steps that we recommend are to send the pre-design report to Nova Scotia Environment and to confirm with them if an environmental risk assessment for the receiving water is required, because this takes some time to complete. And then, if required, to begin that ERA. Also, to begin discussions around land and water lot access or acquisition, to apply for funding, and to begin the regulatory consultation process. And next slide, please. And so in terms of possible timing, we've laid these out on a Gantt chart. And the longest lead time items are the regulatory package, as well as the funding application. But the ERA could also be necessary in that time too, depending on what NSE says about that. So if all of these go approximately to schedule, we could see detailed design starting following the funding application approval in around next summer, and then geotech and bathymetry survey to find out the exact details of the route to inform the detailed design. Once the design is finished, then that could be sent as part of the final regulatory package to the regulators for approval. And once approval is reached for that, possibly around the second quarter of 2023, then it could be tendered, and with construction commencing after that and operational by the first quarter of 2024 approximately. Okay, next slide, please. Okay, and at this time, I'd welcome any questions on the outfall.
I will open the floor. I have Councillor Halverson.
I just would like to know the objections you mentioned. Are there any other objections that, aside from the jurisdictional ones, that could be coming from the regulator?
They need to go through an approval process, and we've aimed towards a location that has sufficiently good dispersion that we think it would be approvable by them. So we don't see necessarily places where the regulators would say, no, you absolutely can't do this. Although it's impossible to say for certain until we've actually had, or until the town has had good discussions with them on the specific project. So during the regulatory review, we tried to identify all the possible regulators that could be involved and what sorts of applications would be needed for them. But the regulator does have the ability to approve or not approve a project. So the better the information that's provided to them in the regulatory package, the easier it is to get an approval from them. And also starting that regulatory consultation process as early as possible to identify any possible places where there could be an objection is recommended.
The main regulator you're talking about here is Nova Scotia Environment, I assume.
Nova Scotia Environment, but also some federal agencies, including
Fisheries and
DFO,
Fisheries,
would be definitely key ones. There are some permits that would be required from the town itself, also potentially from the municipality of the District of Lunenburg. So the regulatory consultation and also land discussions are two things that can hold up the process and should be started as soon as the town has made the decision to proceed in order to make the whole process go as smoothly and as quickly as possible.
Yeah, that was my second question, was actually about, have you had any experience when, one jurisdiction or one body has to, work with their neighboring municipality? What kind of timelines have you seen in order to make that effective, from a regulatory point of view? I mean, obviously we'll have to lean on our relationships, but just purely from a regulation point of view.
Oh, from a regulation point
Well,
of
I
view?
guess, yeah, like how long does it normally take for those approvals to go through? How much longer could it actually hold it up if we decided to go with option 4 at Highlight?
Yes, with option 4, it wouldn't necessarily take longer, but it would be a more involved regulatory process because there are more regulators. There would be more federal involvement because they administer the seafloor in that, or the harbor bottom in that area, whereas option 3 would be contained within a water lot, which would not need federal approval of the same administrative agencies. In terms of relationships with neighboring municipalities, I think there are definitely opportunities for both municipalities to benefit from this work. And so that could help to smooth the process and make it something that both of them can embrace.
Okay, Deputy Mayor, and then I see Councillor Sanford.
Thanks, Your Worship, through Sarah. So I know, Sarah, in your route that you chose goes along basically the Back Harbor Trail. So have you looked at any other routes that you may be able to take? Like if you, for instance, would just come out the outfall as it is and just go along Pelham Street, for example. What would be the difference in costing there?
There would be an increase in cost, certainly, from taking a route that goes along surfaced roads, especially if there's a lot of infrastructure in them already. So the advantage of the Back Harbor Trail is that it doesn't have an asphalt surface, and it also doesn't have a lot of other pipes already in the ground. It would increase the cost and the disruption, we think, substantially in order to take a route that went straight through town rather than going around via the Back Harbor Trail. But we do recognize that that's a very much used trail and that it would involve disruption to residents' lives in the short term in order to relocate the outfall there.
Yeah, no question on the disruption, especially if it went through town. But in terms of Pelham Street, if that was the street we chose, I mean, other than one section, it is in need of resurfacing regardless. And would there be any other long-term benefits, like in terms of, stormwater separation and things like that we could build into that all at the same time? And then looking from a maintenance point going forward, is there advantage? So again, a little more upfront, but maybe a little more savings down the road.
There would be the possibility of including other work with that, like stormwater separation, perhaps. I don't know exactly what the infrastructure in Pelham Street is specifically. In terms of longer term maintenance, it would not be an advantage because if the pipe needed maintenance, then you'd have to dig up the surfaced roads again. So again, the trail is attractive for that reason. There is not expected to be maintenance that requires you to excavate the pipe, but it can happen. And so I think that that's still probably the least disruptive option.
Is it worth, a look at?
Generally, we try to avoid streets that are surfaced with other infrastructure because there's just a lot more to work around. But we could talk with the town engineering team about whether that's something that would be of interest or some other benefits
Yeah,
here.
worth a discussion perhaps. Yeah, thank you.
Okay, I have Councillor Sanford.
Can you hear me?
Can we hear Councillor Sanford?
Trying to see if I can. Can you hear me, Heather?
Say something again, please.
Can you hear me now? Can you hear me now, Heather?
Yeah, maybe you can just read the text and we'll get that issue sorted for the next meeting.
Cannot figure out what that is. Sorry.
Option 3 and 4 effective in the same way. So if we increase density, resulting in more discharge.
If there was an increase in population density, the regulators require that it is treated to the same level regardless. So there wouldn't be an increase in the concentration of the treated effluent leaving the pipe in either case. It would be treated to a greater proportion of the waste would need to be removed in order to get to that same concentration to be acceptable for discharge. So yes, they would be effective in the same way, or they would have the same comparison between the two of them, no matter if there were increased density in the town.
Okay. Any further questions from council at this stage? All right, seeing none.
Thanks very much. That is the end of our presentation today.
Okay.
And thank you very much for your time and for the town engineering team and public works team's help and consultation on this.
All right. Well, then we can adjourn the meeting and we will look forward to the August 4th presentation, which will give us the final aspect of this work. Meeting adjourned.